Manufacturing Insights, Manufacturing Engineering Magazine's video series for process improvement. This program will review concept modeling machines and their impact on new product development. We will look at 3 different machines and see how engineers are adapting their approach to projects to reap the most benefit. We will see concept modelers in use at Raytheon TI Systems, where design engineers are using concept modelers to save time in new product design. And at Union Special, where concept modeling machines are used for new product development, and as a service bureau offering rapid prototyping to outside companies. Then we'll see how engineers at UT Automotive have brought concept modelers upstream in the design process. Over the last few years, concept modeling machines have evolved into a reliable tool for design engineers. Concept modelers translate geometry generated by CAD Solid modeling software to build a physical prototype. The information directs the machine to deposit building material layer by layer. The real advantage to concept modelers is improved communication. The office-friendly machines can quickly produce inexpensive models. As a tool for design engineers, concept modelers provide a 3D prototype to touch and study. It is a chance to catch manufacturing errors at the design stage and a great visual aid to sell an idea. One key point of concept modelers is that they are quick. Depending on the size of the part and the type of concept modeler, a prototype will be created in a few hours or a few days. Another plus for concept modelers is that they are simple to use. Most often, an operator can complete training in a day. The longest training period required to become familiar with the machine is just 1 week. Possibly, the biggest plus for concept modelers is the price tag. With prices in the $50,000 to $60,000 range, concept modelers are affordable to a relatively broad market compared to more traditional rapid prototyping machines.
It's awfully important to recognize the value of being able to take an electronic model of a real, honest-to-God physical part and produce that physical part in physical reality. Think of it as kind of like a spell checker. Spell checker, the role they play for word processors. Well, you can think of this thing as, in a sense, being a geometry checker for engineering 3-dimensional pieces. All right. So there's a basic value that the technology's got, period. So one of the issues there, I think, is that the places where it has been used today, it has clearly delivered within that little activity tremendous benefit. Shortened lead times, better designs. I mean, all of the things that we're looking for have come out of it, and I don't think anybody argues that. But when you stand back and you look at those little areas in the context of the big system that they're in, that doesn't contribute to the bottom line of the system. And I think that's one of the big problems, is that it really needs to find its way into every activity involved in doing a fairly complex system. So I think it's a big step forward. It gets us, in general, beginning to think in 3 dimensions instead of 2 dimensions, and gets that thinking happening in the engineering office as well as in the lab or wherever the other machines are. And it just begins to spread that way of thinking and that way of communicating out into the entire community. So I think it's unbelievably valuable.
Raytheon TI Systems in Lewisville, Texas was an original beta testing site for the Actua 2100 by 3D Systems. Designers working in an engineering environment use the Actua 2100 to make electronic devices for military missiles. The Actua 2100 employs a multi-jet modeling technique. It's similar to inkjet printing, applied in 3 dimensions, with 96 jets on the head, oriented in a linear array. The model builds in successive layers, with each jet applying a specially developed thermopolymer material where needed. The multiple jet head shuttles back and forth like a line printer on an x-axis, building layer upon layer to form the physical part. As the layers build, the model is distanced from the head on the z-axis. If the part is wider than the print head, then it's repositioned by a cross-axis on the y-axis. The building process continues without interruption until the model is completed. Reception of the Actua 2100 at Raytheon TI has been positive.
We design cast parts, basically of a whole variety. Anything from, I guess, potting molds, which aren't actually cast, but then we'll also design mechanical parts, fixtures, and hardware. The concept modelers offer, I think, even faster speed as well as better access to the engineers for the concept parts for use as models and for display type items where you're in a meeting or whatever and you want people to be able to see what you're actually thinking of and make suggestions about the part. That actually runs a lot faster from the standpoint of the engineer.
Just last week we had a design review for our system, and in order to give a good hands-on idea as to what the new configuration of my system was going to look like, we did quarter scale models, and we broke our system up into 4 piece parts, and we were able to do a section view of our system, and it was incredible. We had customers in at the meeting who were able to get a real good look as to some of our problem areas, some of the areas of concern that you just can't show in a foil or an overhead. So it definitely provided a very good means of communicating some of our successes as well as some of our, our problem areas.
One of the big advantages from when you go into meetings with your boss and you try and tell them, explain and show pictures of things, nothing tends to help more than just actually bringing a solid part in there and showing it to them and really have them be able to pick it up and see what you're, and feel and do everything to know what you're really talking about.
Having the machine actually directly connected and within a few feet of our engineering area has very much increased our ability to access the machine and to use the machine on an instantaneous type basis.
We've shortened our design cycle quite a bit with the use of this wax modeler. We've taken initial concepts from ProEngineer, transferred them directly to the machine, which output models for us. We've done check fits, we've used them in our design review, and I would say it's taken weeks off of our design cycle in that we can more quickly know that our design is sound and that all the interactions between the other parts are sound.
Pretty much in all the cases in our area we're using Pro-E for generating the model that we then in turn send to the part. We just generate a standard STL file out of Pro-E and then go into the Allegro, the GUI interface for the modeler, and it's very simple to use. The engineers really like it. It takes about 4 or 5 steps, and then the interface really tells you all of what it's doing and asks you to select the item you want to build, select the parameters, and then it asks you to confirm that that's actually what you wanted, and off it goes. There's very little training actually required. Yeah, the software itself is very simple to use, and then there's a little bit of training on proper operation of the machine and getting the platen and everything in place to get the model where it's ready to run, and then removal of the part and doing the cleanup. Takes a little bit. Mostly it's just showing people where the equipment is to do it.
Although the Actua 2100 has benefited the design cycle at Raytheon TI, engineers have encountered a few bumps in the road.
If they could make it just a little bit softer, I think it might be a little bit more resilient and not be quite as brittle, because it tends to sometimes it'll crumble in your hands if you don't handle it right, or sometimes during cleanup off the actual machine you can damage a part very easily from trying to remove it from the platform. So you have to be very careful with it.
The idea of using the Actua 2100 during a project is new and so requires a change of mindset.
Once they've used the modeler for actually the parts they've actually designed, I think they really like what they see, as well as the speed with which they get parts that they can actually handle. And I think just getting them to use it, once or twice and getting past the training stage so they understand the machine is probably the biggest thing to getting the engineers to use the parts. At
Union Special Corporation in Huntley, Illinois, The original plan was to use the Sanders prototype model maker for in-house investment casting and product development. Very soon, however, outside clients became interested in working directly with the Model Maker Pro, and Union Special took on the additional role of service bureau. The Sanders Model Maker uses 2 movable inkjet printheads to complete the building process. During the build cycle, one head deposits thermoplastic build material, while the other head delivers supporting wax material. Both materials leave the inkjets as hot liquid and solidify upon impact with the cooler build surface. The inkjet heads digitally deposit the build and support material as a sphere, which spreads out on impact to a thickness of 2.5 thousandths of an inch. This selective deposition process permits traces to be placed next to each other to produce a uniform layer of material. Material deposits along a line at rates up to 12 inches per second. Each new layer is established by a horizontal milling tool that machines a smooth and level surface on the model substrate material. The milling operation allows the model maker to build layers as thin as 0.5 thousandths of an inch. This size build layer reduces stair-stepping on the surface of the model to extremely small amounts. Once the model is complete, the support structure dissolves off in a controlled temperature bath. The new Sanders 3D model maker has been redesigned, and one result is the machine noise level is now comparable to other concept modeling machines. Because of its extremely accurate but slow building process, the Sanders machine is not always considered a concept modeler. But for Union Special, the ability of the unit to make extremely accurate wax patterns for investment casting has enabled them to make close tolerance metal parts in 2 or 3 days.
We needed a quick way to get to our castings. Any way we could see how the casting was going to work before any production tooling was actually made up. We needed direct castings. And if we got lucky, some tooling as well. We were able to achieve that, and that's a pretty steady thing right now as well. That was a real added bonus along with a lot of other things, but the main thing was getting to investment castings real quick.
When you get the requests from our customers, they kind of expect it quickly. If you have to say, I can't give you anything for 8 weeks, maybe a window of opportunity may be gone. Whereas in this process, we can truly say, yeah, well, let me bring a part to you next week and see what we can do. A tremendous advantage. And like I said, you know, other people are interested in this kind of a process too, and if we can offer the services, maybe we can make additional business for Union Special.
Passload, a manufacturer of power fastening systems, is one of Union Special's Service Bureau customers.
We needed a means of prototyping the investment casting tooling, because once you make a change, a severe change to the investment casting mold, the wax mold, you're often looking at a new mold. And for something like this part, this comes off at an angle, and there's side action, and there's side action here, there's top action here. It's a very complicated mold. You know, we might be looking at 50 grand with the coining technology and the machining.
In development of this new cordless nailer, Passload engineers revised the design over 15 times and enjoyed the luxury of testing metal parts without paying for production investment casting tooling.
We've made a lot of severe changes to the parts and recast them and recast them and recast them. We've done that all without tooling, and that's a time saver, it's a life saver, it's a politically it's wonderful in the company to be able to do that, because when you're ready to go to production, you've got something that you're very confident in.
Union Special estimates the Sanders models reduces the development process time by as much as a month on some projects. However, that doesn't stop design engineers from suggesting a few improvements to the process.
A little bit quicker would be nice, more durable parts, but the one thing we do need to keep is the castability. We never have any problems getting it through the autoclave, melts out real clean. You know, our casting guys like it a lot. Those are things we have to keep. Maybe get up to 95% reliability on the machines. Right now I'd say we're about 80, 85, but it's working good.
When UT Automotive in Dearborn, Michigan began looking into concept modelers, designers wanted a unit that would shorten development time, require minimal training, and would fit right in the office. One of the machines they use is the Genesis from Stratasys.
It fits right on a desktop. It doesn't take any more space than a designer would. The stereolithography and other equipment, you need a special room, and it takes more training to use it. This one here, we had very little training. We had maybe a 4-hour session with the people when they set it up to take us through the program, and we've got 4 of our designers capable of doing it, and as new people come on board, we're able to train it in-house without going outside for training.
Genesis is a 3D printer that allows a designer to print concept iterations directly from a workstation. AutoGen software orients and scales the part, slices the data, and automatically builds parts with a simple point-and-click command. The Genesis produces prototype models up to 8 by 8 by 8 inches in a durable polyester material. A cassette system that holds 50 wafers feeds material through an extrusion head, which deposits a 13,000th of an inch width stream of material at a rate of 4 inches per second. Genesis produces models to within an accuracy of plus or minus 13,000ths of an inch. At UT Automotive, designers use the Genesis on almost all projects, and the benefits have been substantial.
It's actually shortened our development time. Normally, we would do a design, send it out to get another part made, and that process takes about a week or so the old way, whereas we can do it overnight. Set it up before we leave, and when we come in the morning, we have it. Also, it gives our designers a faster chance to come up with different conception of parts, different generations. We've gone through where we'll do 2, 3, 4 generation, run the parts overnight, and then sit down in the design review and go through which one is the best for the application. We have our Genesis machine seated right in with our design areas. It's no louder than the old pin plotters used to be. Every now and then you'll hear the fan turn on to clear out the heat from within the compartment, but the movement of the slide and everything is just like a regular pin plotter. This here is one project that we used. I'll show you the different iterations we went through as our designers used it to develop the part. So our designer was able to get a part, took some measurements off of it, and then he started designing in stages. And this ended up going to the customer for a final review, which was acceptable. And then from there, we went to the tool vendors. With this model, this helped us not only in developing the part, but helped the tool vendor in developing his tool, because he found areas that the designer missed that caused tool locks, that if the tool would have been built, we probably would have had to scrap or had a longer time to build the tool instead of catching it all up front in these concept models. It's kind of hard to say how much we actually saved in cost. Some projects we've had where they've gone through and we've had no scrap tooling or anything because of the nature of the project. All I do know is the time it took us to go from conception to kickoff tooling, I would say we saved about 4 weeks.
The popularity of concept modelers continues to build, with more being sold each year. In 1997, the Z Corporation from Somerville, Massachusetts, introduced a completely new concept modeling machine. The Z402 uses the Massachusetts Institute of Technology's three-dimensional printing technology. 3D printing uses a printhead to selectively spray drops of binder onto layers of a starch-based powder. Once built, the part is lifted out of the surrounding powder and cleaned off. To strengthen the part for handling, the operator will then dip it in a bath of wax or epoxy. The part can be polished to a smooth surface for a more finished look. With the arrival of concept modelers, a prototype can be introduced sooner into the development process, and that will change how engineers approach a project in the future.
There's a fundamental change in the way that the engineering goes forward. Okay, that's one issue, and people don't like to change. The second issue is that in order to really get maximum benefit out of this kind of new way of thinking, it needs to be applied across the board in all of the components for the product you're trying to manufacture. It doesn't do you any good to produce a Framus in only 5% of the time it used to take if all the other widgets are still taking the same time they always took. There isn't any bottom line benefit to that. So I don't think engineers are, once they're exposed to it and once they see what it can do, I don't think they're reluctant to use it. I do think that management and companies don't quite understand how it's going to change the way they do business, how they will benefit from it. And as a result, there's a reluctance there to spend money on what may be just another technological toy. What effect is that going to have on the engineering process? Well, I think in one instance, if you're thinking about high volume manufacturing, it now is almost for free that you can, along with when you're designing things, start worrying about what's it going to take down here to manufacture this thing in high volume. In a sense, you can extend that to things like service. You can start bringing service guys in and say, look, here's what it's going to look like. Can you get at it? What's it going to cost? How difficult is it going to be to go after the oil filter? Here's where it's going to be. You know, I mean, all of that stuff I think gets facilitated big time by having concept modelers and then the downstream stuff. And what's required now is that the process accommodate that and begin to take advantage of it. And I don't think it's doing it to a whole. It's happening now in isolated cases where, in fact, engineers have this technology. But those are one-offs. It has not been elevated and institutionalized into a new process. And that's what's going to happen next.
With a prototype so quickly available, engineers are free to explore more design options. Having a production prototype in hand for review meetings, design engineers can begin to build stronger lines of communication with manufacturing engineers and the rest of the company. When an inexpensive three-dimensional model of a part is created at the beginning of product development, the result will have a ripple effect on the entire design and manufacturing process. If your organization uses a concept modeler, be prepared for a reduction of your product development cycle, powered by a clearer understanding of early design geometry and the luxury to take risks.